So in this lesson, we explore what the square root function looks like. We were briefly introduced to what a square root function looked like when we looked at the inverse of quadratic functions. Now we're going to expand upon that. So what does the square root function look like? Why does it look like it does? And then what is its domain and range? So we're going to explore this with a t-chart. So we're going to plug in 4, 3, 2, 1, and so on into the parent function, y equals the square root of x. Graph that on the coordinate plane to the right to see what that graph looks like. So if we replace x with 4, that means we're trying to find the square root of 4, and that would equal 2. So the first point we would have graphed would be 4, 2, which would be about right there. And then the square root of 3, so since we're graphing, that is going to be about 1.7. That's an estimate. Square root of 2 is approximately equal to 1.4. Square root of 1 is exactly 1. And what is the square root of 0? Well, the square root of 0 is exactly 0. Then we get down to the square root of negative 1. Now we know from previous lessons the square root of negative 1 equals I. However, there is no I on a real number coordinate plane. So actually, we're not going to be able to take the square root of negative 1 and be expected to graph it. And that's true for the rest of all these negative numbers. We won't be able to take the square root of a negative number in the real number system. So the only points that we have to graph to create our graph will be that 4, 2 we've already graphed. We've got over 3 up 1.7. That is roughly right here. 2, 1.4. That's about, right about here. And then 1, 1. And then 0, 0. So our graph looks like this, starting at 0, 0, and goes up, and it is starting to level out roughly like that, and it continues to get flatter and flatter the further to the right that it gets. The domain of this function is not all real numbers, as you might expect, because you can't use negative numbers. As a matter of fact, the only thing we could use was 0 and numbers to the right of 0 on the graph, or numbers larger than 0. So the domain is x is greater than or equal to 0. And the range is y is greater than or equal to 0, because notice that we never did get any points down here where the negative y values are. So x is greater than or equal to 0 and y is greater than or equal to 0 will be the domain and range of the parent function. It's not always those, depending on how the graph looks and what the equation looks like, and that's what we're going to explore next, is some of the concepts that we've learned at previous lessons also apply to square root functions. The basic form of a square root function, one that can be transformed, is the function or y equals a square root of x minus h plus k. The a is very similar to the a that we've used in graphing quadratic equations. The a is going to give you your orientation and shape. In other words, your distance and direction. So your distance and direction is going to tell you how, if it's going to stretch or compress, and can also tell you whether it's going to be opening upward or opening downward. The h is your horizontal translation, or in other words, that is your left-right translation. And remember, this is the one that seems a little bit backwards or reverse, where if it says plus, it actually goes to the left. If it says minus, it actually goes to the right. And then whatever number's in the k, this is your vertical translation, and if it's positive, it will go up. If it is negative, it will go down. So that's the one that does make the most sense in regards to the vertical translation. So notice that the h is underneath the square root with the x, because square roots are types of grouping symbols, and anytime it is grouped with the x, this is your left-right shift. This is pretty universally true. And the k, it is outside of the square root, it is outside of the grouping symbols, and that is whatever number is there is your up-down shift. So we're going to graph y equals the square root of x minus 2 plus 5, and then we're going to state the domain and range. So in order to graph that, we first need to figure out the starting point, and the starting point is going to be based upon the shift. So we've got that minus 2 that's underneath the square root. So that's your horizontal shift, but since it's minus, it's actually going to be, it's actually going to be a movement right 2, because remember, that's one that kind of feels backwards. And then the plus 5, it is outside. That's your up-down shift, so we'll go up 5. So right 2 and up 5, so I'll go right 2 and up 5, place a point there, and that's the starting point. Then we're going to do a short t-chart, and we need to pick numbers for x so we can plug it in to solve for y, but we've got to make sure we pick the right numbers for x, because if I scroll back up here, remember that certain numbers we could not plug in for x. In the parent function's case, we couldn't use negative numbers for x. So we can't use any number that will make what's underneath the square root a negative number, because we won't be able to take the square root of a negative number and graph it on a real coordinate plane, a real number coordinate plane. So that means I can't use numbers like 0, because if I tried to plug in 0, I would be trying to take the square root of 0 minus 2, which is the square root of negative 2, which is not possible in the real number system. So I can't use that particular number. But what can I use? I can use numbers like 3, because 3, notice 3 is to the right of the 2 on the coordinate plane, and if I take 3 minus 2, that is going to give me the square root of a positive number, and I'm going to be able to do that. So the square root of 3 minus 2 is 1, so I would take the square root of 1 plus 5. The square root of 1 is 1, and 1 plus 5 equals 6. So I will be able to graph the coordinate 3, 6. So I could go over 3 and up 6 and place that point right there. And then I could graph with a 4. So what happens if I replace x with 4? So that would give me 4 minus 2 plus 5, the square root of 4 minus 2 plus 5. 4 minus 2 is 2, so square root of 2 plus 5, and the square root of 2 is approximately 1.4, and I'm going to need to know that for graphing purposes. 1.4 plus 5 would be 6.4, so another point I could graph would be 4, 6.4. So I'll do that now. So over 4 up 6.4. That's not quite 6.5, so it's a little bit less than a half, so maybe about right there. And then I continue to do that with a couple more points. I think 4 points is fine. So if I plug 5 in for x, I'm going to do this one a little bit quicker. That would be 5 minus 2 plus 5, the square root of that. So what's the square root of, what's 5 minus 2? So that's the square root of 3. Square root of 3, when you figure it out on a calculator, is about 1.7, and 1.7 plus 5 equals 6.7. So the graph 5, 6.7 would work. So over 5 up 6.7, so it's about right here. And then one more, so I'm going to go over here between the graphs. So if I plug in a 6, that would be square root of 6 minus 2 plus 5. Square root of 6 minus 2 would be the square root of 4 plus 5. And we know the square root of 4 is exactly 2, and 2 plus 5 is 7. So this would be 6, 7. So over 6 up 7. And should be a smooth curve just like this. About like that is what the graph looks like, because it is starting to level out very quickly. A common mistake on this is to try to go past that last point and make it much too steeper. So I see a lot of students who will go past the last point and try to do this. They'll go whoop and think it's really steep. And that's not true. It should smooth out about like this. Example B, y equals negative 2 square root of x plus 3 minus 1. So we first need the starting point. We look at the shift to find the starting point. And that plus 3 means we are actually going to go left 3. And the minus 1 means we will go down 1. And that is the starting point. So left 3, so 1, 2, 3, down 1. place this as a starting point right there. And so we need to pick some points that will make the most sense in regards to that starting point. So we can't use anything that is smaller than -3 because that will give us a negative square root. So we can use -2, -1, 0, and 1. That should be sufficient. So we will have -2 times the square root of, and then I'll replace the x with -2. It's the -2 from the t-chart. Plus 3. And then -1. So that'll be -2 times the square root of, and -2 plus 3 is 1, -1, and the square root of 1 is exactly 1. So this becomes -2 times 1, -1, and after doing the square root, we should multiply before we add and subtract. So -2 times 1 is -2, -1 gives us -3. So we will have a point located at -2, -3, which places that point right there. And then we'll do it again. This time we'll replace with -1, and then do the process again. So when we replace it with -1, notice what happens. So the -2 and the -1 that starts the problem are going to be exactly the same. But we'll have -1 plus 3. When we add those, we get 2. And when we take the square root of 2, we get about 1.4. And then -2 times 1.4 is -2.8. And -2.8 minus 1 is -3.8. So -1, -3.8 would be another point. So that's left 1 and down 3.8, which is not quite to -4. So, about right there looks good. And now we do it with 0. So replace with a 0. And when we replace with a 0, we get 0 plus 3, which is 3. So we'll have the square root of 3. Square root of 3 is about 1.7, so everything is pretty much the same here. We're just changing a few things. And then when you take -2 times 1.7, that's going to be -3.4. And then -3.4 minus 1 is actually -4.4. So 0, -4.4. So that's not quite halfway. So about right there. And then once more, we'll replace the x this time with a 1. And when we do that, we'll have 1 plus 3, which means under the square root, I'll have a 4. The square root of 4 is exactly 2. And so -2 times 2 is -4, and -4 minus 1 is -5. So +1, -5 is our final point, which places it right there. So notice this one is much steeper at the start, and it's also going downwards, which we might have been able to predict what it was going to look like, because if you look at the original equation, it does have -2 as an a value. So being negative means it is going to go downward. And being a 2, which is going to be not a number between 1 and -1, it's going to be much steeper than the first graphs that we had. So that's why it's going down so steep.